What specific challenges in multi-step retrieval augmented generation, RAG, does the proposed research method address, and how does it improve upon existing approaches?
The proposed research method addresses several specific challenges in multi-step retrieval augmented generation, RAG, particularly the difficulty of designing robust multi-step strategies for complex real-world problems that require multiple reasoning steps and information retrieval. Existing approaches often rely on manually designed prompts or heuristics, which are labor-intensive and lack scalability. ReSearch improves upon these methods by integrating search operations directly into the reasoning process, allowing LLMs to learn to reason with search from scratch, using reinforcement learning without any supervised data on reasoning steps. This framework enables LLMs to progressively elicit reasoning capabilities and self-correct during the reasoning process, as evidenced by the model's ability to recognize and rectify mistakes in search queries. Additionally, ReSearch demonstrates significant improvements in performance across various benchmarks, achieving absolute gains of 8.9% to 22.4% over baselines, showcasing its effectiveness and generalizability in handling complex multi-hop questions.
How does the proposed research algorithm work? Illustrate the mechanism step by step, detailing each component of the algorithm and its interaction with reasoning and search operations.
The proposed research algorithm operates by integrating reasoning with search operations through a reinforcement learning framework. Initially, the algorithm generates a reasoning chain that includes text-based thinking, search queries, and retrieval results, with specific tags, less than think greater than, less than search greater than, less than result greater than, to delineate each component. During the rollout process, when the model encounters a less than search greater than tag, it formulates a search query based on the preceding text-based reasoning and retrieves relevant information, which is then incorporated into the ongoing reasoning process. The reinforcement learning component, specifically Group Relative Policy Optimization, GRPO, optimizes the model's policy by sampling multiple reasoning with search chains and maximizing the probability of generating rollouts that yield higher rewards based on answer correctness and adherence to the defined format. This iterative interaction between reasoning and search allows the model to progressively learn when to search and how to utilize the retrieved information effectively, ultimately enhancing its reasoning capabilities without relying on supervised data.
Can you provide a simple illustrative example that demonstrates how research operates during a typical inference scenario involving multi-step reasoning and information retrieval?
In a typical inference scenario using ReSearch, the model begins by processing a complex multi-hop question, which it breaks down into manageable reasoning steps. For instance, when the model encounters a tag like less than search greater than, it generates a search query based on its previous reasoning encapsulated within less than think greater than tags. It then retrieves relevant information, which is enclosed in less than result greater than tags, and incorporates this information back into its reasoning process. This iterative cycle continues, with the model reflecting on its previous outputs and potentially correcting its search queries if the initial retrieval does not yield useful results. Ultimately, this structured interaction between reasoning and search allows the model to arrive at a well-informed final answer, demonstrating the effectiveness of the research framework in handling complex queries.
What are the theoretical or practical advantages of using the research method compared to traditional approaches in multi-hop question-answering tasks?
The research method offers several theoretical and practical advantages over traditional approaches in multi-hop question-answering tasks. Firstly, it integrates reasoning with search operations, allowing the model to dynamically adjust its search queries based on prior reasoning, which enhances the model's ability to handle complex multi-step problems. This contrasts with traditional methods that often rely on static prompts or heuristics, which can be labor-intensive and lack scalability. Secondly, ReSearch employs reinforcement learning without the need for supervised data on reasoning steps, enabling the model to learn reasoning capabilities autonomously through trial and error, which is more efficient than manual labeling. Additionally, The framework has demonstrated significant improvements in performance, with absolute gains ranging from 8.9% to 22.4% over baselines, indicating its effectiveness in real-world applications. Finally, the generalizability of ReSearch is notable, as it was trained on a specific dataset yet performed well across multiple benchmarks, showcasing its adaptability to various question types and structures.
Can you explain the experimental validation of the ReSearch framework? What datasets were used, and what metrics were applied to assess its performance?
The experimental validation of the ReSearch framework involved extensive testing on 4 standard multi-hop question-answering benchmarks: Hotpot QA, 2Wiki multi-hop QA, Musique, and Bamboogle. The evaluation was conducted on the full development set of Hotpot QA, 2Wiki multi-hop QA, and Musique, and the test set of Bamboogle, totaling 7,405, 12,576, 2,417, and 125 samples respectively. To assess the performance of ReSearch, 2 primary metrics were applied: exact match, M, which requires the predicted answer to match the ground truth exactly, and LLM as a judge, LJ, where a separate model scores the correctness of the final answer. The results demonstrated that ReSearch achieved significant improvements over baseline methods, with an average increase of 15.81% in M and 17.56% in LJ for the Qwen2.5 model with 7B parameters. This validation highlights the effectiveness and generalizability of the ReSearch framework across diverse datasets.
What specific results did the ReSearch method achieve in comparison to baseline methods? Include details about the improvements in performance metrics and any notable observations from the experiments.
The ReSearch method achieved significant improvements over baseline methods in multi-hop question-answering benchmarks. Specifically, it demonstrated an average improvement of 15.81% in exact match and 17.56% in LLM as a judge scores for the Qwen2.5 model with 7B parameters, and an average improvement of 14.82% in exact match and 15.46% in LLM as a judge for the 32B parameter model. Notably, ReSearch was trained solely on the Musique dataset but exhibited strong generalization capabilities, performing well across various benchmarks, including Hotpot QA and Bamboogle. The experiments indicated that training from instruction-tuned models further enhanced performance, consistently yielding better results across all benchmarks and model sizes. Overall, these results underscore the effectiveness of the ReSearch framework in enhancing reasoning with search capabilities in LLMs.